Okay, so in this video, we're going to talk about the boat race problem. This problem is a great way of understanding how an interferometer works. So to explain the problem, we have two boats that travel at the same speed. We're going to call that speed c. This is, of course, supposed to be a reference to the speed of light. These boats obviously don't travel at the speed of light. They're in a river with the water flowing at a rate of v. For this example to work, v has to be less than c. Each boat has to travel a distance of L and back to its original position, but boat 1 in this case is going across the river and back, and boat 2 is going along the river and back. So whichever boat completes the journey in the least amount of time wins this race. So let's try and figure out which boat will do it, and this will help us understand how an interferometer works. Let's start with the first boat and figure out how long it's going to take to complete this journey. So the first thing to note is that if it travels at speed c, and doesn't try and flow against the current a little bit, it's going to travel at an angle. It's going to travel in the wrong direction. We want the boat to travel in a straight path. It's not going to be able to go at its full speed c, or else it will just go in this weird angle and then back across like that. Like I said, we want it to go straight. So before we start, let's define our coordinate system. So we have the positive x direction and the negative x direction, and the positive y direction and the negative y direction. Okay, so boat 1 is going to have to point itself in the negative x direction, in a combination of the negative x and positive y direction, because the velocity of the water from the river flowing is going to push the boat in the positive x direction. So that means that we need to find how fast the boat is going in the positive y direction. So to do this, you probably already figured it out, we can use Pythagorean theorem. So we know that the boat is going at speed c in this direction, and the water is going speed v in the positive x direction. So we need to use Pythagorean theorem to figure out how fast the boat is going in the positive y direction. So it's pretty simple to figure out. We know Pythagorean theorem is c squared equals v squared, and then we'll say plus a squared. So all we have to do is just move v squared over, so we know that it's c squared minus v squared equals a squared. So then we just take the square root of both sides, and that's how fast a is. So that's how fast the boat is moving in the positive y direction. So now that we have the velocity, we can find the amount of time it takes. So we know that the distance equals velocity times time. So that we have the total distance, which is just, in this case, L. So we say that L equals c squared minus v squared square root times time. But we also know that the boat is going across the river and back, and so it's going to travel at the same speed across the river and back, because even though it's going in the negative y direction, the velocity is not going to change. So we can just say that the distance is twice as long as it actually is, and then we just solve for t. So all we have to do is divide. So we have 2L over c squared minus v squared square root equals t. So that's how long it takes for boat 1 to complete its journey. So now let's look at boat 2. So boat 2 is much simpler. We don't need to use Pythagorean theorem. It's traveling along the direction that the river is flowing. We either just have to subtract or add the velocity of the river. So to do that, we know that on the journey there, the velocity of the boat is going to be c plus v, and on the way back, the velocity of the boat is going to be c minus v. And that's it. So now we have to do the same exact thing we did to find the time for boat 1 with boat 2. So just to avoid confusion, I will call this time 1. So we can't simply double the distance in this case because our velocity is different. So we have to just do the equation twice. And we'll call this time A. So then again, all we have to do is divide. So we have L over c plus v equals TA. And then we have to do now the same thing for the distance back. So we have L equals c minus v, and we'll call that TB. So then we have L over c minus v equals TB. So now to find the total amount of time it takes for boat 2 to travel, we just have to add these two times up, and that's our total time. So we have L over c plus v plus L over c minus v equals the total time, time 2. So now to add these up, we have to find the common denominator. So just doing this FOIL out, we get LC minus LV plus LC plus LV, and then over the common denominator of C squared minus V squared. So these LVs actually cancel out. So then we're left with a final answer of 2LC over C squared minus V squared equals time 2. So these are the amount of time that each boat is going to take to complete its journey. Well, it's a little confusing to tell which is actually going to be faster until we plug in numbers. So let's plug in some numbers and see what happens. So let's say in this example that C equals 5 meters per second and V equals 2 meters per second. And we'll say that the total length that they're traveling is 10 meters. All right, so let's figure out what happens here. So from here, we can see that boat 2 is going to take slightly longer than boat 1 to complete the journey. But can we find a general form so that we don't have to do all this math to figure out which boat is going to take longer than the other? We just know for sure if one is going to take longer than the other and just have a single formula. And the answer is, of course we can. But in order to do it, we have to do a binomial expansion. So I'm just going to write out the binomial expansion. Okay, so now what we want to do is subtract these two binomial expansions to see what the difference is always going to be between boat 1 and boat 2. So we'll say that the difference in time equals time 2 minus time 1. And if we subtract these, we get that it's approximately equal to L V squared over C cubed. This quantity is always going to be positive, so that means that time 1 can never be greater than time 2. So that means that time 1 will always be less than time 2, and therefore boat 1 will always win this race. This is exactly what Michelson was expecting to see when he built and tested the Michelson interferometer. But as we'll find out, this is not what happened. Thanks for watching.